Once again, back to my YouTube channel Sriram Devarajan. Today I am going to discuss a problem from KSET 2013 Mathematical Science question paper. This is from Karnataka Set Mathematical Science question paper from the year 2013. I am going to solve the problem and discuss the problem one by one, starting from the problem 1. If G is a group of prime order, then G is first option, non-abelian, second option, abelian but not cyclic, third option cyclic, last option isomorphic to Z, plus. Solution: since order of G which is equivalent to prime, we have a well-known result: any group of order prime is cyclic. Therefore, for this first problem, option C is the correct one. Now, the second one, if f of x is any polynomial degree 19 with real coefficient, then first option f of x as at least one real root, b f of x as 19 real roots, the number of imaginary roots of f of x is 19. Last option no real roots exist for f of x. See, in this problem, f of x is a polynomial of degree 19 with the real coefficient. From the 4 options, we have to choose the correct option. First option, f of x has at least 1 real roots. F of x has 19 real roots. Third option is 19 imaginary roots. Fourth option, no real root exists. Solution. Here n which is equal to 19, which is odd. Again, a well-known result, polynomial of odd degree over R has at least one real root. Therefore, for this problem, second one, first option is the correct option. Now I am going to discuss the third problem. If alpha equal to 1, 2, 3, 4, 5, 6, then alpha square is first option 1, 3, 5, second option 2, 4, 6, third option 1, 3, 5, 2, 4, 6, last option 2, 3, 5, 1, 4, 6. What is given? Alpha 1, 2, 3, 4, 5, 6. I am going to write this one as, first of all, 1, 2, 3, 4, 5, 6. 1 maps to 2, 2 maps to 3, 3 maps to 4, 4 maps to 5, 5 maps to 6, 6 maps to 1. Since we have to find out alpha square. Alpha square means 1, 2, 3, 4, 5, 6, 2, 3, 2 maps to 3, 3 maps to 4, 4 maps to 5, 5 maps to 6, 6 maps to 1. Alpha square means alpha into alpha. 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 1. One maps to 2, but 2 maps to 3. 1 maps to 3. 2 maps to 3. 3 maps to 4. 4 maps to 5. 3 maps to 4, but 4 maps to 5. 1 maps to 2 but 2 maps to 3, therefore 1 maps to 3. 3 maps to 4 but 4 maps to 5, 3 maps to 5. 2 maps to 3 but 3 maps to 4, 2 maps to 4. 4 maps to 5 but 5 maps to 6, 4 maps to 6. For this problem, C option is the correct option. Fourth problem. If C is the unit circle, then the value of integral over C z square minus z plus 1 by z minus 1 dz equal to first option pi I, second option 2 pi I, third option 3 pi I, last option 0. Here in this problem, C is the unit circle. That means mod z equal to 1. Here z equal to 1 is the only one pole that lies on the circle. By Cauchy integral formula, integral over C f of z dz by z minus a, which is equivalent to 2 pi into f of a. Here a is 1, f of z is z square minus z plus 1. What is f of a? That is f of 1. 1 minus 1 plus 1. Answer is 1. Therefore, 2 pi I into f of 1, 2 pi I into 1. Answer is 2 pi I. For this problem, B second option is the correct one. Problem number 5. If T1 of z equal to z plus 2 by z plus 3 and t2 of z equal to z by z plus 1, then t2 t1 of z equal to first option z plus 2, second option 2 by 2z plus 5, third option z plus 2 by 2z plus 5, last option z plus 2 into z by z plus 1 z plus 3. Solution. Here t1 of z is given as z plus 2 by z plus 3, t2 of z is z by z plus 1. We have to find t2 of t1 of z, that is composition of t2 with t1. First of all, write t2. What is t1 of z? Z plus 2 by z plus 3. Treat this one as some capital Z. T2 of z means z plus 2. T2 of z is z by z plus 1. Therefore, z plus 2 by z plus 3 divided by z plus 2 by z plus 3 plus 1. Simplifying, z plus 2 by z plus 3 into z plus 3 by 2z plus 5. These two will get cancelled. Final answer for this one, z plus 2 by 2z plus 5. Third option, that is option C, is the correct one. Problem number 6. Zeros and poles of z plus 1 by z square plus 1 whole square are respectively option A 1 and I comma minus I, option B 0 and I comma minus I, C third option minus 1 I comma minus I, D option I minus I and minus 1. for this problem we have to find zeros and poles for this z plus 1 whole square, z plus 1 by z square plus 1 the whole square. Solution: zeros of f of z is nothing but f of z must be equivalent to 0. Here f of z is z plus 1 the whole square by z square plus 1 the whole square equal to 0. Cross multiplying z plus 1 whole square equal to 0, z equal to z plus 1 whole square equal to 0, z equal to minus 1 comma minus 1, and the poles is nothing but equate the denominator to 0, that is z square plus 1 the whole square equal to 0, z square plus 1 equal to 0, z square equal to minus 1 plus or minus, which implies z equal to plus or minus I. Zeros minus 1 and poles I comma minus I. Here first option plus 1 but we are getting minus 1. Second option 0 but we are getting minus 1. Third last option I and minus I and minus 1, but the third option is zeros minus 1, poles plus or minus I. Third option is the correct option for this problem f of z. We have to find out only zeros and poles. Here zeros minus 1 comma minus 1 and poles plus or minus I. Problem number 7th one. If a equal to 3, 2, 1, 4, then you have to find a with the adjoint. First option 10, 0, 0, 10. Second option 0, 10, 10, 0. let A equal to AB CD and A plus D equivalent to 1, which is equivalent to AD minus BC. Then A cube equal to, we have to find for A cube. Option A, answer is 0. Option B, minus I2. Option C, 3 times I2. Option D, plus I2. Here the problem is given the form of a matrix which is ABCD, which is 2 cross 2 with the condition A plus D equal to 1 and also AD minus BC is also 1. We have to find A cube. Since A plus D equal to 1 means trace equivalent to 1. AD minus BC equal to 1 means determinant of A equal to 1. We know a well-known result, trace is nothing but sum of the eigenvalue. Sum of the eigenvalue, which is 1, and determinant A equal to 1 means product of eigenvalue equal to 1. For this A, which is a 2 cross 2 matrix, the characteristic polynomial is lambda square minus trace into lambda plus determinant of A, which is equal to 0, lambda square minus lambda plus 1, which is equal to 0. Every square matrix satisfies its own characteristic equation. By Cayley-Hamilton theorem, we can write it as A square minus A plus I equal to 0, A square equal to A minus I. Now, what is A cube? A cube means A square, A into I means A. What is A square? A minus I minus A plus A will cancel, minus I, which is equal to minus I2. Since the problem is 2 cross 2, therefore the value for A cube is minus I2. Option B is the correct option. Now I am going to discuss the 9th one. Let Q denote the set of rationals in R, then Lebesgue measure of Q is option A 0, option B 1, option C infinity, option D indeterminate. We have to find the Lebesgue measure of Q, where Q is set of rationals in R. First option 0, second one is 1, third one is infinity, fourth one indeterminate. Solution: well-known result from measure theory, if A is countable, then measure of countable is 0. Here Q, which is set of rationals, is countable, therefore from the result measure of countable is 0. Therefore Lebesgue measure of Q is 0. For this option A, first option is the correct one. Now I am going to discuss the last one, that is 10th problem. If F subset of K subset of L or field extension such that K extension F is 3, L extension F is 6, and we have to find the degree of first option 2, B the second option 3, C 1, last option D 4. Solution: we can write this one as we know very well this one is 6. We have to find six by 3, which is equal to, answer is 2 for this problem. Option A is the correct one. I will upload more problems from the Karnataka set 2013 from the Mathematical Science question paper. Subscribe my channel, share my channel to your friend, and like my channel. Thank you.